Hello everyone, welcome to our new episode. With this episode, I am going to build, concepts towards the idea of income and substitution effects. So we are going to start with talking and defining a demand theory. So actually, it's something that we already learned. The demand is basically an optimal consumption bundle, all right? So there are two demand curves because there are two ways or two approaches to find demand curves. One is called Marshallian demand, which is what we learn in sort of principles in intermediate micro level courses. And then probably you haven't heard of this before, the Hicksian, or sometimes called compensated demand curve. Well, what's the difference between these two? Well, the main difference is how we find those demand curves. Okay, so I will sort of talk about the details in a minute, but let me first sort of describe how we find those demand curves. So the Marshallian demand is basically coming from the utility maximization problem, the maximize utility function, by choosing x. So x, let's say, is a vector of variable, so Rn plus, all right? So it's an n-dimensional vector, meaning there are n goods, maybe 2, maybe 1. So n is some number greater than or equal to 1. So to maximize the utility function subject to p dot x is less than or equal to income. So here, just be careful about this notation. When I write p dot x, I actually mean a multiplication of two vectors. And as a side note, if I have a vector p1 all the way up to pn and another vector x1 all the way up to xn, all right, so they both must have the same dimension, all right? I cannot multiply a vector of a tuple with a vector of triple, for example. It's not possible. So by definition, when I multiply two vectors, how do I do that? Well, simple. This multiplication is equal to p1x1. So I basically multiply each component, sort of component-wise multiplication, and then add them up. Pn xn, all right? We sometimes call this in mathematics scalar multiplication. All right, so this is therefore the standard budget. The expenditure is less than or equal to income, so this is the standard budget, right? Okay, so the Marshallian demand is basically, so a Marshallian demand curve of good I is basically one of the components of this vector which basically which solves this maximization problem. Well, what about the Hicksian demand curve? How do we get xi? Well, the xi is again coming from this vector, but this time we minimize by choosing the x from Rn plus, which we minimize what? P dot x subject to utility of x is greater than or equal to u bar. All right, so this is the Marshallian demands come from the standard utility maximization problem, and the Hicksian demand comes from it's not standard, most of you guys learn it in this level of course, is coming from the cost minimization problem or the expenditure minimization problem. All right, so well, two different approaches. Oh, by the way, we most of the times denote the Marshallian demand as just xi, right? The ith goods Marshallian demand, and we just simply call it demand. And the Hicksian demand, in order to sort of distinguish it from the Marshallian, we usually call this term C, or some textbook write it H, referring to Hicksian demand. Some of them put C, referring to compensated demand, all right? Well, why the term compensated? Well, the Hicks and the Marshall, so I mean, these are basically the names of the inventors, so that's kind of obvious. But what about the compensated? So the compensated, the idea is the following. Here, the income is not fixed, all right? So therefore, you don't maximize or minimize something for a fixed level of income, but what you want to do, you have a fixed level of utility. So the question is, in order to reach to this utility, what is the minimum expenditure, sort of what is the minimum income you need? So put differently, what is the minimum level of compensation I need in order to achieve this utility level? All right, so therefore the compensated demand curve. So clearly the demands in the Marshallian demands and the compensated demands are most of the times are different, mainly because they depend on different set of parameters. So if we need to be a bit more formal, so the Marshallian demand is a function of price vector. All right, so once again, so P is a price vector, price of each good, and then the income. All right. The compensated demand curve, the Hicksian demand curve, on the other hand, depends on the price, once again, but not the income, right? There's no income appearing on this minimization or optimization problem, but it depends on the utility level that you would like to reach. All right. So therefore, the Hicksian demand depends on a parameter which is absent in the Marshallian demand curve. So clearly they shouldn't be the same almost all the points. They may be the same at some points, which actually we will argue later. They will definitely intersect at one point, and exactly at one point, under obviously some certain assumptions. But normally the Hicksian and the Marshallian demands are different behaviors, are going to sort of explain us different behaviors, and therefore they're going to give us different values. All right, so as I said, we're going to come back later and talk about, the Hicksian and the Marshallian demands. But for now, everything I talk about is basically, the standard demand curve, which is the Marshallian demand curve. All right, so the homogeneity. So this is a kind of a property of Marshallian demand curves. So for any good I, the Marshallian demand curves are homogeneous of degree 0. Of degree 0. What does that mean? That means suppose that I increase the price of good 1 to T2 T times P1 dollars, price of good 2 T times P2, and in fact I do this for all the goods available. All right, so let's say T is 2, so I double the price of each good, but at the same time I double the income. All right, well then the homogeneity of degree 0 basically says this is equal to xi P1 P2 all the way up to Pn income. What does that mean? All right, so this is the sort of formal mathematical definition of a function. So a demand function, demand curve is nothing but a function. It maps all the price and the income parameters into some real number. So whenever I multiply, I scale up or down all the prices and the income at the same level, that's not going to change your demand. All right, so think it this way: inflation, right? Inflation is basically scaling up of the prices. So if the inflation rate is like 100%, that means the prices double. But the thing is, if the income also increases at the same rate of inflation, well, then the consumers, the demand of the consumers should not change. All right. So once again, if prices and the income scales up or down at the same level, that's key. So this is why we have T here, and T is same across, as you see. Then the demand should not change. All right. But obviously the inflation does not impact all the prices and the income at the same level. It influences, or it increases some prices higher than the others, and so therefore inflation changes the relative price ratio, and or most of the times income usually do not change with the inflation rate, unfortunately, and so therefore demand usually changes with inflation. But again, if they all scaled up or down, the demand will not change. This is the homogeneity of degree 0. So this is property of the Marshallian demand curve. Well, you may know all this from the, the principles or the intermediate micro, but let me just very quickly review them. So how does demand, again, I'm talking about Marshallian demand, how does demand behave with the income changes and with the own price changes? Well, as the income increases, the demand of a good may increase or decrease, all right? And if it increases, we call such goods normal good. It's normal, right? The richer you get, well, here it's sort of a very tiny increase or decrease. It's a very tiny change. But I can, without loss of generality, just say when you're richer, you consume more. So the positive relationship. When you get richer, you consume less. So there's a negative relationship for an inferior good. And I think the standard examples is like, well, for normal good, traveling, all right? If you're richer, you probably travel a lot more. And for the inferior good, public transportation would be an inferior good. As you get richer, you probably you use public transportation less, instead you buy a new car, etc., etc. Obviously, once again, these examples are like, you're getting richer and so able to buy a car. Del I is not that kind of change. It's a very tiny change, but just to give the motivation, that's the idea, all right? So the income and the demand behavior are changing in the same direction or the opposite direction. So normally, I did not tell you how we drive the demand curve, but the demand curves usually are downward sloping curves, something like this, do not have to be linear. So I'm sorry. I'm not going to come to this. I'm going to come to this later, but let me just say a few things about the normal good versus inferior good without drawing the demand curves, all right? So let's say this is my a budget line, okay? So this is good X, this is good Y. For simplicity, let's suppose that there are two goods. So I know that this is income divided by PX, this is income divided by PY. So if I decrease the price of good X, what's going to happen? Because the PX is now lower, this I over PX is going to be a bigger number. So therefore I over PY, none of them changed. So therefore this point will be fixed. But the income curve is going to shift this way. All right, so this point is going to be fixed. But this part of this straight line is going to shift to the right. So it's going to increase. So this is income divided by PX prime, and clearly PX prime is less than PX. Okay, so how is this going to change the optimization behavior? Well, let's suppose the individual's utility function was this, and so this was the optimal xi initially, but then, this is sort of the new budget curve now, right? And so therefore his behavior is going to increase to xi prime. So clearly from xi to xi prime, the demand has increased. So what happens is like, oh boy. So this is about this for superior good, obviously. So here what I'm basically telling you is that as the price of good it decreases, the demand of this good increases. All right. So therefore, I am talking about change in own price. I just jumped here. I was actually aiming to talk about normal good versus inferior good. I'm sorry for this mix-up. I'm going to come to it. Okay. So the superior good is therefore is it different than normal good, all right? So the normal good, again, the income higher, you consume more. The superior good, the price higher, you consume less. There's a negative relationship, all right? Almost all the goods that we know of are actually superior good, all right? So if for example, Mac computers are getting more and more expensive, you probably think of changing your computer less and less often, so your demand decreases. So that's sort of the general tendency. And again, this is sort of the reasoning. The price decreases, your demand increases. But the thing is, obviously, the shape of the indifference curves matters a lot And because of this, we have those different behaviors, right? So let me come back to the income changes, and let me open up some space here. All right, so I mean, why some goods increase the demand while the others decrease the demand with the income completely depends on the preferences or the utility functions that represent those preferences. So let's consider this example where we have a normal good, all right? So this is the income level. So this is good X, this is good Y. This is income divided by PX, income divided by PY. And then this is my indifference curve. Okay, I'm sorry, they should be tangent to each other. So let's suppose this is the initial, well, I don't need to say Xi because there are two goods, X and Y, right? So this is the optimal X. If you want, you can put star there so that we know it's the optimal. Good. Well, what happens if we increase income? Well, the income curve, the budget line is going to shift to the right because both intercepts are going to shift the parallel way, right? The income is now I prime. So let's say this is I prime. Okay, so this is what the new budget curve is going to look like. I prime divided by PX, I prime divided by PY. So PX, PY are the same. So I'm dividing the income with the same numbers, but I am increasing the number from I to I prime. All right, so the I prime is greater than I. Okay. Now what's going to happen to the demand, the optimal demand? Well, again, if this is my indifference curve, once again, the tangent point, well, for simplicity, I am looking at an environment where the solution is the interior solution. So the new point is this X prime star, if you like. So therefore, income increases, X prime also, the demand also increases, all right? Again, if you like, you can put star. So therefore, there's a positive relationship, and this is a normal good. But what about inferior goods? So what does the indifference curves should look like so that I have this weird relationship? Okay, so once again, this is good X, this is good Y. Let's suppose this is my initial income divided by PX and income divided by PY. Okay, so I'm going to have an indifference curve, something like this. So this is the optimal X, optimal bundle. All right, now I have my budget line here, income divided by PX, I prime divided by PY, all right? And now my indifference curve is, let's suppose, this way, all right? So the indifference curves do not cross one another. That's very important, as we argued, but the new optimal point is this guy, so X prime, and it decreases, right? So therefore, depending on the exact shape of the indifference curve and which point of the indifference curve we are originally at, so these two things matter. If income increases, I prime is greater than I, however, X prime is less than X. So therefore, that is the sort of the relationship between, negative relationship between income. You're richer, but you're consuming less. So therefore, this is an inferior good. All right? Okay, so, the superior good, as I said, the price increases, you consume less. What about Giffen Good? Well, Giffen Good is the following. As the price increases, you're going to increase your consumption, or as price decreases, you're going to decrease your consumption. Some people give the luxury goods as a Giffen Good, kind of. Not exactly, but sort of the idea is there, right? I mean, as, for example, Rolex increases its price, it's probably not going to decrease the demand. Instead, it's going to increase the demand. But that's the idea of Giffen Goods. And why the Giffen Goods happen? Well, the goods are extremely inferior, and so when the price decreases, so the shifts happen this way, all right? So this part is fixed, but shifts on the horizontal axis. But the thing is, the optimal point is not gonna, so this indifference curve shape again matters. So the new optimal point is gonna be somewhere below this, sort of before this xi. So, I mean, at this point, what does this extreme inferiority is gonna play a role in determining the sort of whether the good is Giffen or not. It's gonna come up later. When we talk about substitution effect and the income effect, but at this point, it just know that Giffen goods are extremely inferior goods, and so when you increase the price, all right. So when you increase the price, the substitution effect is very small, but the income effect is going to be huge, and so therefore you're going to behave opposite direction when it comes to the demand. All right, so this is almost 20 minutes, so let me cut here, and next I am going to talk about how we derive the individual demand curves, right? We all know and learn in intermediate micro principles that the demand curve is a downward sloping function. So here we just learned that demand is actually nothing but an optimization, an outcome of an optimization problem. Yes, but how do we actually drive the demand curves? It's coming up next.